Hi everyone, this video is going to be looking at radians. So if you hadn't watched the review video, just got the animation on the screen now, which shows you that a radian is actually the radius of a circle turned into an arc around the outside. So that's how long a radian is, and it fits in 3.14 times into half a circle, or pi times into a circle. So pi, a lot of radians, fits into a half circle. And also 2 pi in a whole circle. Cool. Okay, so I'm going to get out of the PowerPoint now and go to chapter 12a. So the first chapter we're looking at is going from degrees to radians and radians back to degrees, so how to do that. So having a look at these little formulas here, basically, we know that pi is equivalent to 180 degrees. Now this little c is representing radians, but please don't write it. They use it in the textbook a bit, and then they even say here, often the symbol for radians is omitted because we generally know something's in radians because it's written in terms of pi. So if you've got pi on 4, you know that's radians. If you've got 45 degrees, you know that with the degree sign, you know that's the degrees. So we don't really need the little c on it. Anyway, so if pi, say, amount of radians is equal to 180, that means that 1 radian on its own is equal to 180 divided by pi. And 1 degree is equivalent to pi divided into 180 parts. So a radian is 180 degrees divided into pi parts, so it's like a third of 180. Okay, you can see that there. And a degree is equivalent to pi divided by into 180 parts, so degrees are much smaller. So basically, going to the purple box here, if you've got degrees, you just take that number, say it's 60, and you times it by pi on 180, and that will turn it into radians for you. And you'll notice that it will go from a number like 60 to something that has pi in it. That shows that you've turned it into radians. And if you've got radians, say 2 pi on 3, and you want to change it into degrees, you multiply by 180 over pi. And having the pi on the bottom of the fraction is going to cancel out the pi that you started with. So that's going to turn it into a normal number. Cool. Now, so that's question 1 and 2, 3 and 4, exactly the same, but you've got decimals to start off with. 5 and 6, exactly the same process, but you've got a negative out the front. The only thing 5 and 6 will change is if we had to draw those, they'll actually go in the opposite direction to what we've usually measured a radian, so it'll go in clockwise direction, because usually we're going anti-clockwise. But you don't need to worry about that for now. Now you might be thinking, doing these questions 1 to 6, do I need to have my calculator in radians or degree mode? It doesn't actually matter, because when you're putting your calculator in radians or degrees, it's for when you're working with sine, cos and tan. So if you tell your calculator that you want to know the sine of 30, you need to tell it that that 30 is either a degrees or radians. It would be nice if your calculator could automatically recognize that you want sine of 30, that's obviously degrees, whereas if you wanted sine of pi on 6, you're obviously giving it the radians, but it can't do that, so you have to let it know. But in just working things out, going from degrees to radians and things, you don't need to worry about what mode it's in. Question 7, I want you to try and do this without your unit circle that we've made. So I want you to start from scratch. So you draw a circle with the axes and you think, where would pi on 4 be? So have a go at it, and then you can check your unit circle afterwards or use the answers to have a look to see if you got it right. So I don't want you to just get out your unit circle and copy those positions, okay, because that would be pretty pointless. Cool, that's 12A done. Thanks for listening.